Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast.
Good morning. This is Gregg Lippa with Themis Education. Today we're here to talk about the JDBC. How does Java connect to database? A copy of these slides are available on the bottom line at www.themisinc.com/webinars. Today our topics are JDBC, how to use JDBC to connect to the database with the JDBC driver, how to call SQL statements and use SQL with statement and prepared statement, and how to process the query results using the JDBC ResultSet object. We'll talk a little bit about performance. We'll talk about error handling, stored procedures, which are called with the callable statement in JDBC. We'll talk about the Java side of stored procedures, a little bit about transactions and isolation level, and then we'll wrap up with a brief look at object relational mapping and how that relates. If you have questions, please use my email address you see at the bottom of your screen, glippa@themisinc.com. Two general approaches to SQL are static and dynamic. With dynamic SQL, the SQL is not seen by the database until runtime and therefore must be compiled and optimized during the execution. This is going to take longer and also not reveal any errors with the SQL until runtime. Static SQL is when you precompile and bind your SQL statement so that efficient access is stored in the database as a plan or package. Security can also be applied to the plan, allowing only authorized users to run that type of statement. The downside of static SQL is this need to bind up front, and that JDBC does not support it except through stored procedures. The benefits of dynamic SQL: because the optimization happens at runtime, the latest statistics are available to base those decisions on the database, and a better execution plan is possible. However, a major disadvantage with dynamic SQL is the increase in the cost and time of running the statement. So in a high transaction environment, this can be a major problem. Static SQL, very typical in the mainframe world with COBOL and DB2. Dynamic SQL, the norm in a distributed world, an object-oriented Java world, but stored procedures give you a way to avoid the dynamic SQL and simply call a stored procedure that has been already compiled and bound. As many of you know, stored procedures are SQL statements stored in the database. They provide a number of benefits in addition to performance. They also help with security. JDBC has an object that allows you to call stored procedures. It's called the Callable statement, and we'll take a brief look at how to use Callable statement. We will not look at how to write stored procedures, and that varies from DBMS to DBMS, different, for instance, in Oracle versus DB2. So JDBC, Java Database Connectivity, is a set of interfaces. You can think of these as contracts in the Java language that specify what every database needs to be able to do to support database calls from Java. These interfaces are then implemented by database drivers. Database drivers are code that's written typically by the database vendor, like IBM or Oracle, and fulfills the contract that's defined in those interfaces and allows access to different kinds of databases using the same type of code. So JDBC is a kind of an application programming interface that allows you to access relational databases in a vendor-independent way. The overall structure of how a Java application works is step 1, connect to the database. Step 2, execute your queries and updates, and then process query results. And finally, disconnect. Those steps are at the high level. Doing the actual database work is the primary part of what needs to happen. In today's dynamic web-based world, our client typically is sitting at a computer and accessing your application through a browser, such as Internet Explorer. And the Java code is running on an application server, such as WebSphere or WebLogic or JBoss. These are Java Enterprise Edition, Java EE servers. And that's where your code that accesses the database would reside, that would use the JDBC API and the drivers that have been loaded to support the database work you intend to do. And then that server would be able to talk to a database server either on a different machine or on the same machine. The database driver is supported through JDBC's driver manager. So when your application needs to access a database, it needs a driver to be able to do that. Depending on what kind of database you're accessing, you're going to have a supporting driver for that database. And in order for the application code to actually use the database, that driver must be loaded. And I'll talk about a couple of ways to get the driver loaded and available. First, using manual approach, and second, using what's called a connection pool. There's also a capability of reusing ODBC, Open Database Connectivity Drivers, which predate Java database connectivity drivers, using a special bridge driver that allows you to bridge that gap between JDBC and ODBC. So again, as an overview, you obtain a connection, do the work, and then terminate the connection. Steps 1 and 3 you may not be familiar with if you're a mainframe DB2 COBOL programmer, because the connecting and disconnecting on that platform is automated through the code generated by the DB2 precompile. But the database activities are where your primary work will be as a developer who needs to access the database. You would use a JDBC statement object or a similar object like a prepared statement. You would use it to perform queries, which are select statements, or updates, which include insert and delete as well as update. And then you would retrieve the query results from a query or the update counts from an update. Depending on what kind of SQL you're running, you'll either get back a result set or a simple whole number that tells you how many rows were affected by the updates you did. Loading the database driver, again, this is something that is not typical in a server-based application where connection pools are used. The code for that is right here, class.forName, which tells the Java environment to load the class. This class is JDBC ODBC driver, which resides in a certain package. And the second example, the class name is DB2 driver, which resides in a different package. Loading the driver causes the driver to register itself with the driver manager. So we can then make a connection to the database using that driver if it has been loaded. Because the name of the driver is contained in a string, it's possible that there's a typo in that string, or that the class is not available on the class path. So a class not found exception is possible, and you see how we put the code into a try-catch block to support that potential problem. Now that you have the driver loaded, you're ready to actually get the connection, and the driver manager class supports the ability to make new connections to the database using the getConnection method. That method accepts either one parameter or three parameters. The one parameter version simply specifies the URL of the database. This database URL identifies which database you want to connect to. We'll see another URL on the example in the next page. The three parameter version of getConnection, which you see here, accepts the user ID and password as well, and security is typical, certainly in an enterprise environment, so having an ID and password is the norm. The structure of these database URLs is roughly something like this. It always starts with these four letters and a colon, and then the rest of it is dependent on the type of database you're connecting to. So we'll take a look at connection code here on the next slide, and what you see is here where we did the getConnection, we have the database URL as the first parameter. That's a variable, string type variable with this value. So the database URL, JDBC, :db2, and then the location of the database, the port that it's listening on for connections, and the name of the database instance at that server location where the database is running. We also see the username and password, which have been hard-coded for demonstration purposes here, passed to the getConnection method. So this sample code shows that we are loading the driver, and the driver name is also in a string contained up here. So it's the DB2 driver. And then getting a connection. Con has the type of connection. Like all the JDBC interfaces, connection lives in the java.sql package, which we've imported. So we are creating a connection and allowing this variable to contain a reference to it. We can then use con, that variable, to do the rest of our database work. In this case, we're not doing any database work. We're just printing out a message that says we connected. And then in the finally block of our try-catch, we're calling the close method to destroy the connection. You notice an additional catch block, the class not found exception we talked about when you do the forName method. And the other exception we're catching is an SQL exception, which just about every JDBC type call is able to throw when it's not happy with the way things have operated. So this example just shows how to connect to the database and then how to disconnect. To actually use the database to do useful work, we would need something like a statement object. So what we've done down here is told that connection object we need a statement by calling the createStatement method. And a statement, if you think of the connection itself as the road between your application and the database, then you could think of the statement as the truck or vehicle that carries the SQL to the database and carries the results back from the database. Now, in this example, createStatement has no parameters being passed in. It does have a couple of optional parameters that support features of result sets, including scrolling and updatability. We'll see that in a minute. Now, in order to use the statement object, you need to execute either a query, which is a select statement, or not a select statement. Update, insert, delete, create, alter, drop, grant, revoke, all those other kinds of statements are executable with execute update. Again, execute query returns a result set, which then needs to be processed, where execute update returns a number, an int, a whole number, that tells you how many rows were affected by the call. So here are the examples. RS is the variable that we've defined to support result sets, and when we call execute query, it returns that result set, where when we call execute update, it returns that row count, which is simply an int value. So in this example, select was used to execute a query, rows with a name that start with S, and execute update was used to execute a delete based on the ID. Now, the other capabilities of a result set are scrollability, which allows you to back up and jump ahead. The default is that you can only go one by one from the beginning to the end of the result set. And the other capability is updatability. The default may not be updated. We'll show you how you can update through a cursor using the concurrency settings. So if you have a scrollable cursor, in addition to the next method, which is always available for any cursor, you can also back up, jump to the beginning or the end, or even before the beginning or after the end. And you can also move a relative number of rows, like back 5 or forward 10, or you can move to an absolute position, such as go straight to row 7. Here's some sample code that shows in the create statement passing in these two optional parameters. You need them both. So even though we're only trying to implement scrollability here, we need both parameters to be specified. Then we execute a query using a select statement, and here we jump down to the bottom after the last row and then loop backwards using the previous method. And for demonstration, we then jump straight to row 4, back up 2 rows, which would take us to row 2, and forward 3 rows, which would take us to row 5. A big chunk of the work that needs to be done once you've positioned yourself onto a row in the result set is retrieving the column values. Again, unlike the mainframe world where you simply fetch into on your cursor, with Java, after you've positioned on the row, you have a set of getter methods that you use to get the value each column on that row. So it's often important to know what type of data is in there. For instance, if it's packed decimal data or if it's whole number data, and then you can use the correct type. GetString is capable of converting most types, such as date, time, number types, to a string. While this isn't an exhaustive list of all the types that are available, XML support is demonstrated here or indicated, and blobs and clobs are also supported, although not shown here. Now, every one of these get methods has 2 versions. You can either pass it the name of the column as a string or the position of the column in the select statement as an int. We've done both in the example at the bottom. There's a column whose name is cost, and we have called the getBigDecimal method, which returns a big decimal type object containing the numeric value of that cost. In the other example down here, column 3 we don't show its name here. We may not know its name, but it's the third column in the select list. Or if you select asterisk, it's the third column on the row. So either an int value or a string value is passed in to any of these get methods in order to retrieve the data from that column. So you need to, if your row has 30 columns in it, you need to call 30 of these get methods to get all of the data in that row. And that can be a lot of work. That's where object relational management can help, and object relational mapping, and that's something we'll talk about briefly in a minute. When it comes to result sets, there's the possibility of nulls being part of the result, and depending on the type of data that you're retrieving, you may get back a reference type like a date or a string, in which case you can simply test for null like we've done here. However, if you're getting a primitive type like a double or an int, then they cannot be null. So 0 is what's provided by the driver, and you need to call a special method designed to determine if that column had a null value. That method gets called immediately after you make your call to get the, in this case, primitive value, quantity, which is a double, and then ask the result set if that last call returned a null value. So there are ways to handle nulls. As far as updatable result sets, this is available through the update methods. There are, like we saw with the getter methods, there are a whole set of update methods for each type that you want to update. The update methods also similarly support using the column position or the column name to determine which column needs to be updated, and then their second argument provides the value that you want to place into that column. Now these update methods, again, there are dozens of them. These update methods only update the result set, not the actual row in the database. So after this kind of an update, you would then have to push those updates out to the database with an update row call, or perhaps cancel or delete instead. Here's an example. Again, both parameters have to be supplied, even though this is the default, and this is the one that we needed to set, concur updatable. Now we run a query, get back all of our products, and then start walking through one by one. And for each row, we go ahead and get the value in the quantity on hand column, then add 10 to it. So for our inventory, we've received 10 of everything, 10 each of everything, so we're going to add 10, and then update the int value. We did a get int, so we're going to probably be using update int as well to update that same column with the now higher quantity. Then write that update back to the database. The next 4 slides are a complete JDBC example. What you see is a class called useDatabase with a main method making it runnable. And this class does really the same thing twice. It does it here and does it again here. And the outputs similarly relate. The top half of the output relates to using an access database, and the bottom half relates to a DB2 database. So you can see we've got a different database URL and a different driver on the top than we do on the bottom. We have a database URL and driver. This entire application is driven by a class called ProductTable, which appears over the next 3 slides. And ProductTable is a data access type class. It encapsulates the data access. And it supports these kinds of methods. This is our variable that reflects the product table object. that's being instantiated with this constructor call and pass the database URL and driver name. Then we get a connection, ask it to create a connection, do some inserts, and then do a select statement to show all the products that have been inserted, producing this output, and then shutdown, which disconnects to the database. Same series of calls down below as we see up above, the difference being that in the Access database, when we create the connection, there is no security there, so there are no additional parameters. On the DB2 database, when we create the connection, there is security required, so we pass in an ID and password in order to create that connection. Here's the product table definition. It has 4 fields or instance variables, including the database URL and driver that got passed in through the constructor. This is the constructor, and those fields are then stored here on in this portion, and then the connection and statement are used to support the actual use of the database to run SQL. Here's the 2 create connection methods. This is, of course, overloading. This one taking no parameters, this one taking 2 strings, so that the ID and password that are passed in here can then be used on the get connection call. Where here there is no ID and password used on the get connection call. All this does is make a connection. That connection is the same variable either way that we saw on the previous slide that will be used throughout the rest of the running of this application. Next, we see the showAll products. This demonstrates the query, execute query. It's a select statement and creates a result set. We begin before we loop through the rows. We print out a couple lines of header with ID, name, and quantity and a separator. Then we go through and get the int from the column named ID. We don't see the column names here, but we have ID. And then we get the string from the column called name. And then we get another int from the third column, whose name might be quantity or quantity on hand or something like that. So this produces the row of output where each column value is separated by a tab character, and each row is separated by a new line character using the print line statement. Notice also that the result set and statement are closed, but not the connection. That remains open until we shut down. And that's what we see here. Shutdown is where we close the connection and handle the exception. Also on this page, the insert product, which takes 3 parameters to support the 3 columns on the product table. Now, the approach of this application is to first delete the row. So the ID that came in is plugged into the where clause right here, and that identifies which row needs to be deleted. And secondly, then, we do the actual insert. That's the SQL insert statement, and the values, again, are provided by the parameters and the arguments that were passed into this method. So we have ID, and then a comma, and then a single quote, and then the name, and then another single quote to enclose the name in single quotes, another comma, and then the quantity, and then the close paren. So you might look at this and notice that it's a little bit cumbersome to work with, where we have to concatenate the special characters like the commas and parentheses and single quotes around strings. Of course, no single quotes around numbers, quantity and ID. Now, execute update, while it does return a number telling you how many rows were affected, we ignored that number on the delete statement because we didn't care whether it deleted it or not. but we do check that number on the insert statement. We expect that one row will be inserted. One other page that doesn't relate to the example that we saw back on page 22, but does relate to the product table, is a method called getProductList. A sample call to it down at the bottom shows that it returns a list of product. List is a Java collection class that is like an array, if that's something that you can relate to from your programming background. So we are actually using an array list of product, and we also have a product object. This again, very much where object relational mapping comes in and simplifies things. We have what is often called a persistent class, meaning that product is a Java class that relates to the product table in DB2 or in the database. And so what we've done is gotten the data from the product table and extracted it with this code, telling the result set to get an int with the ID and a string with the name and another int with the quantity. We've gotten that data. Then P is a reference to the product object that's being created with that data, and on this side we're calling the setter methods to take the data that was retrieved from the result set and use it to populate the three fields or instance variables in the product. So again, with real data, with dozens of columns, this could be a whole lot of code, a whole lot of really busy work, and this is where object relational mapping really comes in to help out. After we've created and populated that product, we then add it. P is the product now being added to product list, which is this thing containing an array list of products, which is ultimately returned from this method to fulfill this contract of returning a list of product. The PreparedStatement interface allows for parameters to be passed in. If you've coded any, again, COBOL DB2, you've certainly used colon host variables to do that. The question mark is how that happens in Java. That's what you see here. We want to select from products where the name is equal to something that we're going to set a value into before we run the statement. So again, we use the connection object, only instead of calling createStatement with no parameters, we call PreparedStatement with the SQL passed into it. And that produces, instead of a plain old statement, a prepared statement. Now, each question mark in the prepared statement is positional, so this is question mark number 1, the only question mark in the statement. And before we can execute this query, we have to provide a value for each one of those placeholders. And since the name is a string type, we call the setString method. Again, there are methods for all the different types: setInt, setDate, setDouble, and so on. And we're setting the name of the product we're looking for to left widget. Here's another example where we have a file that contains data that's going to drive our application. And in this while loop, we are reading through the file line by line and retrieving an ID and a name, which are going to be used to fill in the 2 question marks in the delete statement. Delete from product where ID equals something and name equals something. So we go ahead and read those 2 values at a time using statements like this. And now we have values for the ID and name, which for the first row of the file, or for the first 2 rows of the file contain those values, which are then used to set the question marks in the prepared statements and execute the update and keep track of how many rows have been deleted. Then we loop back up, read again, reading in the 7, 8, 9 and the right widget, and plugging those values into the question marks, and then executing again. So this demonstrates how you can use a single statement repeatedly with different values to support each execution of the statement. Connection pooling, extremely important. Basically says, since we only need a connection for a relatively short time, the length of a transaction in a transaction processing environment, that because of that short time, the cost of creating and destroying the connection is actually oftentimes much higher than the cost of running the query. So what connection pooling does is work with the database ahead of time to create a set of connections that are then available, and instead of creating a connection when you're ready to do some database work, you use a JDBC lookup, Java Naming and Directory Interface, to find a data source, which is a connection pool, and get the connection from it. Instead of the connection being created at that time, you're simply borrowing it, like checking it out of the library, using it, and then returning it when you're done so that it can be used by another request. The performance implications of this are enormous. It's really the only reasonable way to operate in a server transaction-based environment. Here's the code for a JDBC lookup. This line basically says, hey JDBC, I need you. JDBC's like a phone book or the yellow pages. And this line says, I'm now with my reference to JDBC CTX, I'm going to do a lookup based on this name, which by convention starts with these 5 characters and then has the rest of the name. That availability of JDBC to look up things is not limited to data sources. So lookup returns all kinds of different objects, and this is called casting, where we've identified the type of object that we're expecting from this name. So this would replace the loading of a driver and getting the loading of the driver, and instead gives us a reference to a data source, DS, which is then used to get the connection. And at that point, you use the connection just like you had in the prior examples. Error handling in Java is done in a try-catch block, and the JDBC type calls throw a type of exception called an SQL exception. The SQL exception class supports both the SQL code and the SQL state, as well as a vendor-specific error message like you might be used to receiving from your own database. So any kind of JDBC work that you do in that try block may throw this kind of exception, and here we've printed some output from it. In addition to errors, you also have the possibility of warnings. And while SQL errors cause SQL exceptions to be thrown at your code, warnings do not get thrown. They must be explicitly requested. And so here we have an example of a JDBC statement that we fear may produce warnings, and we go and ask for the warnings. We tell the connection to give us all the warnings. And this loop prints out the warnings. If there were any warnings, we print out information about the warning And if multiple warnings were thrown by the database or raised by the database, here we can walk through the chain and get additional warnings as well. This same approach, get next warning, is used on the exceptions. It was not shown, but get next exception is also possible. One SQL statement throwing multiple exceptions. Slide 34 basically says the finally block of a try-catch is the best place to close a connection. If that connection came from a connection pool, it goes back into the pool, and if it was created by the driver manager, then it's destroyed. But the finally block, because it runs whether or not any exceptions are raised, is the ideal place to make sure the connection does get closed. Stored procedures are a little bit like prepared statements in the way they're called from Java. The difference is that in addition to parameters that come in, the way we saw with the stored procedure, there's also a possibility of parameters used for output. Stored procedures can return values through these parameters. So the callable statement is used instead of the prepared statement when you're calling stored procedures. And there's a slightly different method of connection called prepareCall that prepares the callable statement for execution, and then it gets executed in either of the two ways we saw, or in a third way if there is no output expected to be returned from the stored procedure. For instance, if it returns a ResultSet, then we would execute query. Otherwise, we might just call execute as shown in this example. So this is the key portion here where we have a stored procedure called getName that takes two parameters. One, the first parameter is the ID, which is passed into this method as an argument, and that's an input parameter. And the second parameter is an output parameter that contains the name that's returned by the stored procedure after the call. So for the input parameter, we have to provide a value. And what we do is take the value that was passed in and set the integer value of that parameter. For the second parameter, there is no value yet. We have to register that output parameter will return, the second parameter will return a certain type of data, in this case character data. And then after we execute the query, we can go into that second parameter and retrieve the name that was returned by the stored procedure. So this method says, pass me an int containing the ID you want to look up, and I will return a string containing the name that was found. Should just be name there. Very briefly on transaction processing, most of you are familiar with commit and rollback. Commit makes your changes permanent, rollback undoes your changes. One thing to be aware of in JDBC is that most drivers automatically commit every statement that executes by default. So it's necessary to turn off that auto commit feature in order to make sure that you commit when you want to, not when every statement runs. In other words, if we want this delete and this insert to be part of a single transaction, then we would turn off the auto commit and commit when it succeeds, and if something goes wrong, then roll back instead. Isolation level, not a topic I want to talk about, just to show you that on the connection you can set the isolation level to any of the supported types. DB2 supports all these types. Most other databases support some, but not others. And there are a set of constants that are defined in the connection interface to support the various isolation levels. We'll wrap up with a very brief look at object relational mapping. The problem is what we call a paradigm mismatch, that database tables are a little bit different than Java objects. Tables have rows where objects have other structures as well. And part of the job of object relational mapping is to take the fields or instance variables of a class and map them to the columns of a table. Number of other differences mentioned here, all kinds of capabilities of object-oriented programming that may or may not map well or easily with relational databases. So overcoming the paradigm mismatch can lead to a lot of coding. So ORM-type tools allow us to automate much of this. The persistence of Java objects to relational tables. You've got an object that you've created in Java and you want it to be used as the source of data to create a row in the table or to update a row. Or you also might want to retrieve rows from the table and produce a set of Java objects like we saw in the example earlier where we had an array list of product. So this transformation from one representation to the other, that is from Java to DB2 or DB2 to Java, is handled by the ORM tool. It uses metadata to do this. That has traditionally been XML, but is now more and more becoming Java annotations since Java 5 introduced that. And it allows you to do the create, read, update, delete types of tasks in an automated way. It supports transactions, has excellent optimization capabilities in many cases, and addresses all of the necessary issues, including persistence, dealing with inheritance. On the query side, there's a query language that supports the usual things that we see in where clause, order by, and group by clauses. And it really simplifies your development in Java using relational databases. So less coding, easier to maintain, focusing on the business logic instead of the details of writing that persistence code. It might be surprising that it could actually improve performance, but the folks that write these ORM tools are major experts in databases, and they implement all sorts of features that not every database programmer might be able to do as well. So it's possible that you could produce an application that performs as well, but it might take a lot more time and trial and error to do that. It also insulates the application from the database so that if you switch database vendors, it would be an easier task. Now today, JPA, Java Persistence API, is part of the Java specification, and it supports all the kinds of things that we just talked about. JPA is part of the specification, and among the tools that implement this are the ever-popular Hibernate, Eclipse Link, OpenJPA. There are a number of others that support this object relational management capability to simplify your database programming. Just want to point out that Themis has a full suite of Java-related coursework, including 2 weeks of introductory courses, an enterprise course that focuses on the server environment, object-oriented design, and many other specific courses, including JPA and Hibernate. Stay tuned for our upcoming webinar on how to use Java in the mainframe batch environment. And thank you for coming. Please feel free to contact me, glippa@themisinc.com, if you have any questions related to Java or training in general. Bye now.